Logarithmic spiral galaxies exhibit a rigid, highly specific physical architecture. This physical reality emerges from an enduring friction between continuous, unbounded analytic spaces and strict, discrete geometric constants. We analyze this through the theory of infinity, or TOI, ontology. This framework treats numbers as context-dependent phenomena generated from natural symmetries. Within TOI, dimensional intersections yield outputs known as transcendental shadows. A transcendental shadow occurs when a continuous wave function is confined within a strict boundary. The resulting integral encodes the precise algebraic ratios needed to construct a stable geometric form. Decoding these mathematical shadows provides proof that the chaotic void of space is governed by exact, discrete geometric blueprints. The investigation centers on the fluid darkness operator and involves a fractional Fresnel-like sine moment where a continuous wave's phase accelerates at a non-integer rate. Evaluating this operator over a normalized unit vacuum produces a bizarre transcendental scalar. To a standard solver, this result appears to be arbitrary numerical noise or debris. Our objective is to formally decode this chaotic scalar and demonstrate that it dictates the dominant pitch angle of galactic density waves. The mathematical canon follows strict epistemological rules. Claims cannot rely on approximations. They must climb a rigorous status ladder to verify their stability. Integrating this mechanism into book XX of the canon requires elevating this anomaly from a monitored residual to a state of sealed exactness. The canon enforces the Tri-Modal Invariance Rule, or TMIR. This classification system categorizes mathematical claims into geometry, algebra, or discrete modes. Transitions between these modes are monitored for not-infinity events. These occur when a mathematical operation attempts to extend an object beyond its closed system, resulting in division by zero occurrences or non-terminating growth. Resolving these infinite boundaries requires an ether, a background potential that carries structural forms without selecting a preferred coordinate system. To extract localized geometry from this unbounded potential, we apply the master orthogonal filter law. Before evaluating the volatile fluent darkness wave, we must construct a mathematically unblemished vacuum space, an environment that preserves values without scalar distortion. The master orthogonal filter projects a continuous function against an inverse power decay curve on a separate orthogonal axis. By applying Fubini-Tonelli constraints, this two-dimensional double integral separates exactly into independent one-dimensional scalars. We define the filter by setting both the scaling parameter and the exponent explicitly to the golden ratio, phi. This chart displays the resulting orthogonal identity plane. The decay curve swooping along the infinite x-axis limits the total integration to exactly 1. Because the recursive property dictates phi equals 1 plus its inverse, the scalar coefficient self-annihilates, creating an exact unit seal. This golden unit seal provides an exact mathematical environment where complex trigonometric functions can be tested without distortion. Within this vacuum, we introduce a continuous sine function, warping its argument into an accelerating phase state, sine of x to the power of phi.
In classical calculus, integrating sine functions with squared or higher power arguments yields Fresnel integrals. These functions possess no elementary antiderivatives and are used to map wave optics and diffraction spirals. Raising the argument to the fractional constant of phi creates a fractional Fresnel wave. Here, the phase oscillation accelerates nonlinearly as the variable approaches the unit boundary. Since the function lacks an elementary antiderivative, integrating from 0 to 1 forces the evaluation of a highly compressed downward crest, triggering a not-infinity event. Standard continuous calculus cannot solve this wave. To achieve TMIR compliance, we must find an alternative path to the solution. We reach sealed exactness by expanding the integral using the infinite Taylor series for the sine function. Substituting the warped phase argument allows the integration and summation operators to commute seamlessly over the unit interval. We then apply the third Bolden filter, specialization, to scale the series. The factorial denominator ensures rapid convergence, stabilizing the final mathematical output. This evaluation yields the fluid darkness constant, a stabilized transcendental scalar of approximately 0.154508499. To a standard observer, this number is indistinguishable from random noise, but it represents a precisely sealed geometric shadow. We now perform a reverse algebraic extraction to pull discrete golden ratio geometry out of this decimal debris. The sequence begins by taking the absolute value of the fluid darkness scalar and multiplying it by the fundamental circle constant, pi. This transformation aligns the data into an exact geometric coordinate representing 18 degrees, or pi over 10 radians. Doubling this resulting scalar shifts 0.154508499 precisely to 0.30901699. This doubled value is inextricably bound to the inverse golden ratio, proving that the continuous wave was concealing exact geometry. We must ask why multiplying a fractional wave integral by pi and doubling it manifests a golden ratio baseline. The answer lies in the interior algebraic exactness of the Golden Pentagram. A pentagram inscribed in a circle generates internal golden triangles with base angles of 72 degrees and a 36-degree vertex. Bisecting the top vertex creates a right triangle containing an 18-degree angle. In this specific right triangle, the ratios of the side lengths scale invariably to the golden ratio. The physical geometry of fivefold symmetry necessitates the 18-degree angle, the exact mathematical coordinate we extracted from the fluid darkness wave. Finalizing the Canon integration requires the algebraic proof of the trigonometric identity for sine of 18 degrees. We expand the relationship between 36 and 54 degrees using double and triple angle identities, isolating sine of theta. Substituting the Pythagorean identity creates a definitive quadratic equation.
Solving for the positive root yields an identity of 1 over 2 phi. This represents the terminal algebraic identity. 1 divided by 2 phi equals 0.30901699, the exact doubled value of our fluid darkness scalar. The fluid darkness calculus functions as the exact sealed mechanism required to translate continuous dimensional spaces into rigid observable structures. With the trigonometric coordinate of the Golden Pentagram extracted from a fractional continuum, the mechanism for galactic density waves is formally ratified into Book 20.